we already proved some differentiation rules, including how to differentiate function x to the power of n, logarithm, the natural logarithm specifically, and also the sum rule, and we've seen how we can apply those rules. We need to also derive other relatively simple differentiation rules. One of them is the constant multiple rule. So you can find this in section 5.2.4, and we're going to very simply demonstrate it. The constant multiple rule essentially tells you that if you have something like k times f of x, if you differentiate it, you get k times the derivative of f. It's very simple. It's also very simple to actually prove this by remembering key properties of limits, including the fact that if you have some constant multiplying the limit that does not depend on how you're taking the limit, you can always take it out. But let's do this in practice and with mathematical rigor. One thing that we should always try to do, so we can use a definition of what a derivative from first principles is to call this g of x. It could be h of x, anything you want really. And under this definition, g of x is equal to k f of x, which also means that g of x plus h is k f x plus h. These are the two key ingredients to differentiate from first principles. What we want to then calculate is the derivative of g of x, which is equal to the limit when h goes to 0 of g of x plus h minus g of x. And we already have it here, but we'll spell it out for clarity. X plus h minus g of x over h. We sub it in. So this is equal to the limit when h goes to 0 of k f x plus h minus k f of x over h. The crucial step before we can prove this differentiation rule is to understand the key property of limits, and we have k being multiplied by both sides, so we can actually take it out of the limit because there's no dependence in h. So we can write this as k times the limit when h goes to 0 of f of x plus h minus f of x over h, which with the definition of derivative from first principle, we can recognize it as the derivative of f of x. And therefore, we've demonstrated this differentiation rule. It can be this simple. This is obviously a very simple rule, very simple demonstration. But these are the key ingredients, the key steps that you need to take to prove them. And from now on, you can definitely use this differentiation rule.